habitations in the towns we know. A place we saw the lights turn low, the jigsaw jazz and the get fresh flow. Pulling out jobs and jamboree handouts, 2 turntables and a microphone. Bottles and cans, or just clap your hands, or just clap your hands. Where's that? I got 2 turntables and a microphone. Where's that? I got 2 turntables and a microphone. Where's that? Got 2 turntables and a microphone. Where's that? Got 2 turntables and a microphone. That was a good drum break. Pick yourself up off the side of the road with the elevator bones and your whip flash tones. Members only, hypnotizers move through the room like ambulance drivers. Shine your shoes with your microphone blues. Your suits with your parachute boots. Passing the Gucci from coast to coast like a man, Gary Wilson. Where's that? I got 2 turntables and a microphone. Where's that? I got 2 turntables and a microphone.
What about those who swing both ways, AC/DCs?
Let's make it out, baby.
Part of the total scene.
Where's that? I got 2 turntables and a microphone. Where's that? I got 2 turntables and a microphone.
That's beautiful, Dad.
past my maps. We'll meet on edges soon, said I, proud neath heated brow. Ah, but I was so much older then, I'm younger than that now. Half-right prejudice, leave before, rip down all hate I scream. Lies that life is black and white, spoke from my skull I dream. Romantic flanks of musketeers, foundation deep somehow. Oh, but I was so much older then, I'm younger than that now. In a soldier's stance I aim my hand at the mongrel dogs who teach, fearing not I'd become my enemy in the instant that I preach. Sisters fled by confusion boats, mutiny from stern to bow. Ah, but I was so much older then, I'm younger than that now. So much older then, I'm younger than that now. My guard stood hard when abstract threats, too noble to neglect, deceived me into thinking I had something to protect. Good and bad, I define these terms, quite clear, no doubt, somehow. Ah, but I was so much older then, I'm younger than that now.
time to close now. I know I have to go now. I really wanna stay here all night. All night. All night.
Girl, you really got me now. You got me so I don't know what I'm doing. Girl, you really got me now. You got me so I can't sleep at night. Girl, you really got me now. You got me so I don't know where I'm going, yeah. Oh yeah, you really got me now. You got me so I can't sleep at night. You really got me. Oh, you really got me. Oh, you really got me. Please don't ever let me be. I only wanna be by your side. Please don't ever let me be. I only wanna be by your side. Girl, you really got me now. You got me so I don't know what I'm doing, yeah. Oh yeah, you really got me now. Got me so I can see.
Good afternoon, everybody, and welcome to our first Geo-Institute live stream of 2023. This marks the fifth, that's a whole hand, year that we have been live streaming at the Geo-Institute, and we are really excited that you're back with us for another great year. My name is Brad Keeler. I'm the director of the Geo-Institute. Hopefully you know me from other GI entities such as Director's Cut. Today, though, we have a special treat for you. As you may have known, we are getting ready for Geo-Congress 2023 in Los Angeles, which will be held at the end of March. I have my Geo-Congress 23 hat on today. I also have my Geo-Congress 2022 student competition t-shirt on. And here in front of me, waiting patiently, is Carl Terzaghi. If you like what you see today, and I think you will, you should click like, subscribe, and get notifications. And of course, we will let you know every single time we post something to the YouTube channel. This is the third in a series of 4 Geo-Congress sneak previews. And as I said, we've got a treat for you today. From the LA Metro, Michael Harrington will be with us talking about the Regional Connector Project. And here to tell you a little bit more about that is our Geo-Congress 2023 conference chair, also from Los Angeles. From HNTB, it is Yoga Chandran. Yoga, take it away.
Thank you, Brad. And for those in the West Coast, it's good morning. And those on the East Coast, it's good afternoon. On behalf of ASCE, I would like to welcome you to the January edition of the live stream presentation hosted by ASCE Geo-Institute. As Brad said, my name is Yoga Chandran. I'm a Senior Vice President at HNTB and excited to introduce our speaker. I'm also the General Chair for the Geo-Congress that will be held in Los Angeles from March 26 through 29 in Los Angeles Convention Center. So we hope to see all of you there. There'll be a lot of exciting presentations on both state of the art as well as state of practice that will be shared. Hope you will learn a lot and share your knowledge with the attendees over there. Today, as Brad said, we have an interesting presentation on one of the major projects that's been constructed in Los Angeles. And I would talk to my LA Metro friends, and they would say Regional Connector is the best project in Los Angeles, if not in the whole United States. So I hope our featured speaker, Michael Harrington, would agree to that statement. Michael Harrington is a PE and is an executive officer for LA Metro LA Metro's Program Management Department. Michael holds a BS in Civil Engineering, a BA in Business Administration, and is currently a candidate for an MBA. He has over 26 years of experience in rail transit design and construction management, and currently serves as the engineering manager for LA Metro's $2 billion Regional Connect to Subway project in downtown Los Angeles. And I would say that any project in LA starts with the B, a billion or more. And this is one of those. Michael has overseen the engineering of this complex and challenging mega project for the last 6 years as it nears an opening in spring of 2023. Prior to joining LA Metro, Michael worked in the private sector on several high-profile rail and transit projects throughout the United States. Please join me in welcoming Michael Harrington to give his presentation on LA Metro's Regional Connector Transit Project. Over to you, Michael.
Okay, appreciate that, Yoga. And I assume that everybody can see my screen and hear me still okay?
Absolutely.
All right, very good. Okay, well, good afternoon, everyone, and good morning to those of you still on the West Coast. The title of my presentation today is LA Metro Regional Connector Transit Project Approaching Substantial Completion. And the agenda topics that I'm going to cover today is I'm going to provide a brief project overview, going to get into some facility details and descriptions, then talk about some design and construction challenges that we've experienced over the last few years, and then wrap up with a very brief discussion on lessons learned that might be applicable to some of your projects. So with that said, let me get into a brief project overview. For those not familiar with LA Metro's transit system, this is a map. Metro is aggressively trying to build out its system, trying to catch up to where we probably should be as a metropolitan area for the size of the population that we have. That said, our current system is, hopefully you can see my cursor here, okay. Our current system is, our light rail system is pretty much dominated by the blue line, which comes up, you can see my cursor from downtown Long Beach, comes up from the south part of the county, and then terminates in the southwest corner of downtown Los Angeles. Downtown Los Angeles is in this circle area here. We also have our Expo line, which connects from Santa Monica, comes in from West LA, and then also terminates at the southwest corner of downtown Los Angeles. Now, if you flip over to the east side of downtown, we have our Gold Line. The Gold Line connects Azusa, Pasadena, LA Union Station, and then turns easterly out to East LA. Right now, these light rail systems are disconnected. And what we're trying to do with Regional Connector is link all of those up so that we can have one-seat rides from a south to north direction through the county, as well as from the west to east through the county. And what that's going to do is eliminate potentially up to 20 minutes in some of our commuters' travel times from all of the transfers that they need to take today. Some other highlights or statistics about the project. It's not very long. It's 1.9 miles long. It comes up Flower Street, makes a sweeping turn easterly underneath 2nd Street, and then connects into the existing Gold Line in the Little Tokyo area of downtown. We are building, as part of this, we are building 3 new underground stations to better serve downtown. We are anticipating, at least this was pre-COVID, we were anticipating 90,000 daily trips. We are planning to run trains eventually at 2.5-minute headways through the corridor. Our full funding grant agreement is $1.755 billion, but if you add in the soft costs and local matches associated with this project, we're closer to $2 billion. We are anticipating, as Yoga said, a completion in 2023, hopefully in a few months here. And we are delivering this project under 2 contracts. One was an advanced utility relocation contract, but most of it's being delivered through a design build contract through a joint venture of Skanska Construction and Traylor Brothers. Now, a little bit more about the facilities that we're building. This slide's a little bit busy, but what I wanted to show here is this is an exaggerated soil profile of downtown Los Angeles. If you can see here to the right, this is the Little Tokyo area where our project starts. It goes underneath 2nd Street. We have our new historic Broadway station. I'll get into the details in that in a moment. And then again, for those who are familiar with downtown Los Angeles, we have this area called Bunker Hill. This is where our arts district is, Disney Concert Hall, a few new museums that have opened up, big tourist area. Anyway, this is our Bunker Hill area. We're building a new station to serve this area called the Grand Avenue Arts Bunker Hill Station. And then we transition underneath Flower Street, a major artery through downtown Los Angeles, and tie into our existing 7th and Metro station. Now, a little bit about the soil profile for the geotechnical engineers on the call. I wanted to zoom in here. For this particular project, we did generate a geotechnical baseline report. This was part of the bid documents that was included in the design build solicitation. But if you zoom into some of the profiles, give you a flavor of what we were dealing with from a tunneling standpoint. The green here represents our tunnel profile. And then in our project, we primarily were tunneling through a layer called the Fernando Formation. It's predominantly a massive siltstone or a soft rock. It was actually ideal for tunneling, a very soft rock, easy to tunnel through, yet it was very stable. You could cut into it vertically and not have to shore it. Above that, though, we did have alluviums. We had coarse grained sediments, sand with some gravelly sands, variable amounts of cobbles and boulders. That was atop this Fernando Formation. And as you approach the LA River Basin, that area or that layer got a little bit deeper and more pronounced. But anyway, moving on, this is an aerial view of our Little Tokyo station. This was taken back in 2016. You can see here in the right, this was our existing gold line, and we had an existing at-grade station, which has since been demolished, and it's being replaced by a new underground station here across the street. In fact, when this photograph was taken in 2016, if you look closely within our supportive excavation system, we actually use this as the launching point for our tunnel boring machine. You can see the cutter head and the shield there real closely, and then our trailing gear went actually underneath the temporary deck that we had underneath of Alameda Street and First Street. This is a rendering of what the finished station will look like. It's pretty much a cookie cutter station for all of Metro's newer stations. We're trying to streamline the design, make roofs, lighting systems standard across all of our stations to reduce costs, especially maintenance costs and spare parts costs. And when we were building this particular station in Little Tokyo, these are some representative samples of our shoring systems that we used. I think we pretty much used just about every tool that is in the book that you can use on this project. For example, in the upper left-hand corner, we used a soldier pile and lagging system. In this particular area, we additionally shored the system with several rows of post-tension tieback anchors. In this lower photo here to the left, you can see we've used some pipe struts. Because we had to support roadway decks in some locations, we used pin piles. And this is just another photo of the various types of shoring systems that you can see in this area. I was also going to add real quickly for our waterproofing membrane systems, we are using an HDPE high density polyurethane waterproofing membrane seam. It has welded seams. That's what's shown in the black lines here. And we also have a supplemental, it's called the Fuco hose system, a remedial grouting system that allows us to repair leaks that show up after we've completed construction. And this is what that station looks like today. This is that wall, the completed wall. The shoring system is right behind this artwork in this cast in place wall here. And this is what it looks like up at the plaza level of our stations. This is another view of the station. Right now, and we're in the phase of the project where we're just wrapping up mainly some architectural finish work and then doing some final station cleanup, getting ready for revenue services. In fact, our operations group is running trains right now, doing what they call pre-revenue testing, again, trying to support an opening here in a few months. Moving over to our historic Broadway station, local landmark in this vicinity is the old LA Times headquarters complex. They actually took up a whole block of downtown Los Angeles. This is a historic mid-rise structure over here. And then around that were some 1960s and 70s era additions, including a large parking garage. Anyway, the station itself, the station entrance area is not going to be terribly exciting when it opens at on opening day. However, the unique thing about this station is it is designed to accommodate a high-rise and mid-rise structure above the station. In fact, if you can see my cursor here very closely, that is our station entrance structure. So we did enter Metro as an agency. We entered into a public-private partnership development agreement with this particular developer. Metro got a very steep discount on our land acquisition costs or easement acquisitions for this area. In return, we did design the structure to serve as the foundation for this mid and high rise structure. And the private developer did contribute some construction funds for this particular station. Now, some other unique things about this station, it was very constrained from an access standpoint. In the background here, this is the historic part of the LA Times building, and this is the older parking garage. But at this particular location, our station was about 70 feet deep. We had to keep 2nd Street open to traffic. There was just too much traffic and would have been too impactful to downtown to close for multiple years of construction here. So we did have to keep it open. So we built temporary roadway decks built suspended by pin piles mostly. This is what it looked like under that temporary roadway deck. We had multiple utilities that we had to hang. In fact, and you can see up in the upper left-hand photo here, this is a major storm sewer interceptor line. We actually, a creative cost-saving measure implemented by our contractors. We used a Hovis fiberglass pipe to replace a concrete one. It was much lighter, which allowed us to suspend this from the temporary roadway deck above. But anyway, it just gives you a flavor of the complexity of the utility hanging that went on. And the other thing I was going to add is because it took so long to hang the utilities and the excavation took so long to get down to additionally save overall construction time, we allowed the tunnel boring machine to actually go underneath the excavation site. And as we excavated or exposed down after the tunnel liners were put into place, we exposed them. We had some throwaway tunnel liners that we just demolished, and then that allowed us to get down to the invert of the station. And this is what it looked like when we actually reached invert. Again, soldier piles and lagging, post-tension tieback anchors, struts, you name it, we used it. The other thing I want to point out, and this was a little hairy for us, is if you can see my cursor here, that is actually the basement of the LA Times headquarters, that 10-story structure that you saw in the photo that I showed you earlier. We actually had to underpin it. The foundation came out into the public right-of-way, and we had to design an underpinning system. And that took us about a year to design, get approved by the city and the various stakeholders, but was very successful. And what you're looking at here in this photo is the cast in place guideway structure. This is where our tracks go, where our platforms go. And this is what that area looks like today. This is our platform area. And these are some of the finished walls with the that were in the previous photo. The LA Times headquarters building foundation entered into that area. These are some more photos, what it looks like in January. Again, really finishing out the architectural work and cleaning up at the platform levels of the station. Now, our third new station, this is going to be the deepest station on the entire metro system. It's 100 feet deep. The unique thing about this station is not only is it has a pedestrian bridge and it's 2 stories above finished grade, but passengers will actually get down into our station via 6 high-capacity, high-speed elevators. Because of the depth of the station, it was determined to be impractical to use a series of stairways and escalators to get down there. So we were using elevators. We modeled this station after one that was built by Sound Transit up in Seattle, as well as one that's existed for years out in Washington, D.C. on the D.C. Metro system. And this is what it looked like when we were excavating for that station because it was so deep. Again, to put it in perspective, you see that little orange dot there, that is a construction worker. We had 5 rows of struts that are 5 layers of struts that we needed for this particular station, and many dozens of post-tension tieback anchors. We also had to construct a utility bridge. Our new station actually crossed underneath what is Second Place in downtown Los Angeles. So we were able to close this stretch of roadway here, but we had to maintain the utility. So we had to build a utility bridge through there. And then these next photos are showing how the station was constructed as we were coming back up. As we built the invert, as we continued to build various floors and the concrete cured, we were able to remove the pike struts and cut off the tieback anchors as we moved up and eventually backfilled the site. And this is just some more progress photos showing as we were building the permanent structure back up to grade. We also had to, in this lower left photo, hey, we had to construct a seismic joint. We are in Los Angeles. We are in a seismic zone, so we had to construct a seismic zone joint that allowed for differential settlement and movement between the station and the bored tunnel segments. And I'll get into the bored tunnels in a second here. But anyway, this is what the station looks like today. This is the interior, the platforms, and then up at the street level, the landscaping is now in, and some other features of this station. Again, like the other stations, really primarily focused right now on architectural finishes and an elevator lobby, because this will be our primary means of access for our customers, transit users. We did try to make this an enjoyable space. We have glass curtain walls to support our glass elevators to reduce that, so we didn't have a claustrophobic feel as people were entering the station. We also have this six-story piece of artwork. This is $1 million piece of artwork. This is all small mosaic tiles that goes up along the wall of our open elevator entrance shaft. Now, moving into Flower Street, some challenges that we had with Flower Street is this is right through the heart of the financial district of downtown Los Angeles, a lot of high-rise buildings. When these high-rise buildings were built, the shoring systems, the tieback anchors, were left in the public right-of-way. We did not want to bring the tunnel boring machine through this area. We felt it was too risky because if we hit those tiebacks, we thought we didn't want to take a risk of damaging the machine and having to do an emergency excavation. I think for most people on the call or phone right now, they probably are familiar with Big Bertha up in Seattle. We did not want to repeat that down here. So we made a strategic decision at Metro to do this method of construction, cut and cover, rather than bringing the tunnel boring machines through this area. Again, these are just some examples of the shoring system that was used. Again, a lot of hanging utilities. And this is when the invert was being placed and our waterproofing membranes were being placed. Now, I am going to, before I get into some other areas of the presentation here, I do want to talk briefly about how we built our bored tunnels. We did use an earth pressure balance machine. It was a machine built by Harrington in Germany. The diameter was about 17 feet. You can see our cutter head here. This was actually the third project that this particular boring machine had been used on. We started our first tunnel, our west tunnel, in early January 2017. We finished in July of 2017. Then what we did is we disassembled the cutter head and the shield, brought it back up to street level, transported it by truck back to Little Tokyo, and then built the second tunnel. It was just too congested downtown to try to remove the entire boring machine at this location under Flower Street. You can see some of the trailing gear here. Second tunnel was completed in January of 2018. It took a little less than 6 months to build that second tunnel. TBM was then disassembled and transported off-site. Some key challenges that we had with the tunnel boring machine work, we really had to thread the needle with our horizontal and vertical alignments. Just to give you an example of what we were dealing with. The red actually represents we did use BIM extensively on this project. We had to go underneath a major storm sewer line, as well as there's a Metro heavy rail subway line that we had to go underneath. And we were within we were within 2 feet of that existing subway line. So we had to obviously make sure our survey was rock solid and that we didn't actually bore right through our red line subway. But that was very successful. We were able to get through that area without damaging the existing red line subway tunnels. However, we did strike, and I think we all held our breath collectively when we did this. The tunnel boring machine did strike an abandoned pile, steel pile, that was not on any record plans. Our particular boring machine, though, surprisingly was able to chew it up almost like it was gum. These are pieces that came out through the screw shaft and the conveyor belt, and we were able to navigate that, fortunately, without having to do an emergency rescue of the tunnel boring machine. Also, despite our best efforts to miss abandoned tieback anchors, we still hit a few that were unmarked. These are just some examples that came out. But again, unlike I talk about Big Bertha up in Seattle, unlike that particular project, we were able to tunnel through it. Have to say some really good things about the Harrington products. Really built well. And this is what the tunnels look like inside. We built a walkway. We buried our utilities in the walkway. This is what the bored tunnel segments look like today. Some supplemental measures that we installed. We were very, very concerned about settlement during not only the station excavation, but the tunnel boring work. In the Japanese village area, especially, we were tunneling. The profile was relatively shallow through here. So we did use compensation grouting pipes. We drilled an array horizontally underneath all of Japanese Village Plaza. In case we did have settlement, we could use those to remediate or push up the ground if it did settle. The thing about this is, Metro, we spent a lot of money on it and never had to use it. But again, it was better safe than sorry. The other thing we did was monitored very closely ground movement in this area. For example, we did use an SAA or a shape accelerometer array in this area. In fact, it was so precise, you can actually see some of the technology that's been developed over the last few decades. It's just quite amazing. This is a representative sample showing how this is real time. It's sped up, but this is real-time measurements of when the tunnel boring machine was going underneath Little Tokyo Village. You can actually see the pressure wave in front of the machine measuring point. In this displacement, we did have about 0.2 inches of uplift, but then it came right back down when the tunnel boring machine passed. Anyway, it was really good news for Metro. We got through that area without any damage, without any noticeable settlement at all at the end of the day. And then finally, I want to touch on, this was what I would consider the most challenging part of our project. We did have to build an SCM cavern, or sequential excavation method cavern, and this was to support a track crossover that was needed for our operations. For those who don't know what an SCM cavern is, this is a technology that was developed by the Europeans a couple decades ago. And what it allows you to do, I should go back one slide. The reason we needed it is where we needed to put this crossover, where we needed to connect the two bored tunnels, was directly underneath the corner of the LA Police Department's new headquarters building. And it was also underneath the corner of a historic building. So we couldn't do an open cut in this area. So what we did is, again, we used the sequential excavation method. It was 290 feet long, 58 foot wide, 36 feet high. And what it is it's a series of, you do a series of 5-foot excavations longitudinally into the ground. And then what you do is you temporarily support your excavation with basically a shotcrete temporary liner. It's a partially reinforced shotcrete liner. So as you excavate 5 feet, you install your lattice membranes, you put a shotcrete liner in. After that is stabilized, then you go another feet. So you, again, sequentially advance 5 feet. And then you also do it, the way we did it is we did it in 3 drifts. We did a left drift, then we did a right drift, and then we did a center drift. And this was as a photo of the right here showing after all 3 drifts were built with the temporary liner, then the contractor was able to go in and remove the unnecessary shotcrete liners that were needed. As you can imagine, extensive engineering was put into this. It was about as complex as it gets. We did use 3D analysis to simulate the construction sequences. We did a 2D soil structural interaction, dynamic analyses. We had independent design checks, and we also had a tunnel advisory panel. It was a very experienced PhDs, probably had, each one of them had an average about 50 years of experience that reviewed every aspect of our design. And these are just some more progress photos. Again, this is the left and right drifts being completed and the contractor removing the middle drift. These are some photos as the permanent liner was being installed. This is the shoring work that was required for that. And this is what the SEM cavern looks like today. That is our brand new number 8 crossover. And then finally, just some loose ends here. We did, because we were tunneling underneath the Disney Concert Hall and Culver Music Center, we did have to use floating track slab segments in this area. What this is basically precast supports for the track work that sit on rubber pucks. And what that does is it dampens the vibration so it doesn't propagate up into the foundation and into these music venues. So this was part of our environmental document that we had to do that, and this is what the finished product looks like. So we had extensive laboratory testing, mock-up testing before all of this work was installed now, and we're actually in the process right now of doing some final in situ testing, and so far it seems to be working out very well. Some key lessons learned. You know, I could talk a lot about this, the various lessons learned, but I think for this group, what I do want to reiterate is we did have a very robust monitoring and mitigation settlement system in place. I think that's essential when you're doing these very challenging underground projects. Pretty much utilize every tool that you can. Money well spent. I will say though, our water intrusion methods, I think this is something that as an agency we do need to revisit. The HDPE is great if your structures are square or rectangular, but where you have angles or rounded joints, it's very difficult to work with. You can see all of the welds and the small pieces that we had to construct, and ultimately in some of these areas we did experience leaks. Fortunately, we do have the grout hoses. We're able to remediate. It's ongoing right now, able to remediate some of this leakage that you're seeing by doing high pressure grout. But nonetheless, HDPE was very difficult to work with some of these difficult geometry areas. And then finally, can't emphasize how important it is to take advantage of the newer technologies that are out there. 3D modeling, the BIM modeling, clash detection systems, very critical on these mega projects, especially when you're working in these dense urban environments. So with that, I'm going to stop my presentation, and I'm going to turn it back over to Yoga and Brad, who I think are going to facilitate the question and answer session of our presentation today.
Michael, thank you very much. Exciting project, and listening through on the complexities, both on the soil profiling as well as the challenges you face, either the open cut excavations or tunneling. So audience, if you do have any questions, post it on chat, and then we can pull that up and read those questions for Michael to respond to. I do have a question, Michael. I just, as I was listening through and been involved in some of the deep presentation that we have, deep excavation that we've seen, there's always some challenges, the surface settlements or more deflection. And did you encounter any of these? Or if you did, what did you do to control it? or or did you take any special measures so it didn't have that happen in excavations you had?
Yeah, great question. I'm going to go back to a slide to tell the story here a little bit. See here again. Okay, we'll go to this one. All right. So the good news is that throughout our project, we had very little settlement. The only area that we did observe some settlement was, if you see my cursor here, in the center of the street, the SEM cavern that I showed to you is, if you can see my cursor, is right off, if you can imagine, is right under the street over in this location. Now, the SEM cavern method, inherently, you're going to experience some settlement there. And we did have 2 inches of settlement within the crown of the roadway. But as you got away from the crown of the SEM cavern, the settlement dissipated to almost nothing. Now, fortunately for us, we anticipated this, and the roadway construction that was there, it's all asphalt concrete. So it was relatively easy for us to come back in and just build a new roadway crown profile with asphalt concrete, and we were able to repair that. So we had some good news there. The only other location, we were very concerned because we were underpinning the corner of the LA Times, mid-rise building, 10-story building. Very concerned about that. The ironic thing about that is we basically had no observed settlement at all of the foundation. We were able to stabilize it. We had tilt meters. We had water levels, you name it, whatever's in the toolbox. We instrumented the heck out of this building. We also had a robotic total station that was set up across the street. We had targets on the buildings, and it would rotate every 30 minutes, and we would get real-time data that we could actually go onto a GIS-based website, that those that had the password and access it, we could get real-time data. However, we actually had some deflection of one of our walls here adjacent to this parking garage. And after the fact, we determined that we probably should have used longer tiebacks in this area. We were dealing with some limited easement limits in this area, so we were really pushing the envelope on the design here. And we did have, full disclosure, we did have a little bit of damage to this parking garage, to the foundation and first floor of this parking garage. Now, the ironic thing here is that this is slated for demolition. The adjacent property owner here is in the process of getting ready to construct 2 high-rise towers in this area. So as an agency, I think we really lucked out. But with this, of all of our buildings, all of the monitoring receptors through this area, this was the only area that we had a noticeable settlement.
Thank you, Michael. I do see a few questions that are coming in, so thanks for posting. The first question, Ian Gidley. Sorry if I didn't say your name, pronounce your name correctly. The question is, where were the SAAs installed in Little Tokyo, and were they embedded in the street? I'm guessing it's accelerometers.
Yep. So I'll go back to a slide here to show how we did it. All right. So I went through this relatively quickly, but again, you could probably do a whole presentation just on this system alone. But to get your bearings here, if you can see my cursor, this was our first and central, what we call our Little Tokyo Station supportive excavation area. This was our west wall. This, if you can see my cursor here, this is the Little Tokyo, or Japanese Village Plaza. We call it JVP for short. If you're not familiar with Los Angeles, this is a big tourist area, gets a lot of people, especially on the weekends. Very, very sensitive site for us. Also has some historical significance in this area. So basically for the agency, unacceptable to have any settlement or damage to these buildings. So we did set up the SSA array. We actually drilled horizontally. It varied a little bit in depth. If I had to pick it, I'd say it averaged about 15 to 20 feet below the finished ground surface that you see these people walking on, that's where our SSA array was horizontally drilled. And we drilled them all from this west wall of the station. And we drilled them right above. The tunnel boring machine was launched right underneath this SAA array. And they went all the way out. You can actually see this alignment here that you can see here. That is actually 2nd Street in downtown Los Angeles. So the array went almost all the way into the middle of the street. So yeah, it went entirely underneath the plaza and underneath the sidewalk and partially into the street.
Thank you. That's pretty extensive monitoring over there. The second question is from Vishnu DLG. The question is, was groundwater an issue, and how was that treated during the tunnel boring?
Yes, groundwater was an issue, believe it or not. We are, you think we're in downtown LA, so it wouldn't be an issue, but that's actually not the case. I'm going to go back to one of my first slides here. So to give you an example, in downtown LA, the groundwater profile is actually shown here in the blue. And we did encounter groundwater, especially, we thought our worst area was going to be in, the Grand Avenue Arts Bunker Hill station. But in reality, it was really at the 2nd and Broadway station. We did have to, we had pumps, basically dry wells that had to be temporarily constructed to draw down the groundwater in this area. It was a challenge for us because we're using a soldier pile and lagging system. We didn't have a whole lot of hydrostatic pressure buildup on these walls as we were drawing down the water table in this area temporarily, because the water was able to penetrate the seams in the lagging. But nonetheless, yeah, it was challenging for us just to keep this area dry until we got the HDPE liner installed and the station work constructed.
Thank you. The next question is from Krishna Chowdhury. His question is, wants to know what software was used for numerical simulation of tunnel construction. Do you know the software?
Yes. So full disclosure, I am a civil engineer. I am not a geotechnical engineer. I had to rely heavily on our geotechnical experts for this project. I do know that we used FLAC extensively on this project for various elements of this project. But what I can do, Yoga, is let me get some better information on that, on precisely what was used for the tunneling portion. What I don't recall, this goes because this design work was done back in 2014, is I can't recall offhand which elements were designed using FLAC and which ones used other software packages. So I'll have to get back to you on that one.
Okay. Thank you very much. There's another question that was posted as well. You talked about number of construction activities in busy streets and intersections. Was there any difficulty, or did you have to take any special measures to minimize impact to public during construction?
Yes, we did, Yoga. I'll just wrap up by saying, I'll pull up a photo here. Trying to find it. There we go. The short answer is yes, and probably where we encountered that the most was Flower Street. Again, this is a major. It's hard to for those who don't know. This is a major downtown thoroughfare. North is to the right here. Because of the amount of traffic on this roadway, especially during the work days, the work week, we could not do full closures of the roadway during the week. And keep in mind, we had to do an open cut and cover in this area. So what we had to do, talking about it, it's almost crazy to think that we pulled this off, but we had to build a temporary bridge deck all the way from 4th Street down past 6th Street and down to Wilshire Boulevard and beyond. And the way we did that is we would use the weekends. We were allowed to close the roadways on the weekends, and every weekend for over a year, we would put in our CIDH piles, and put in our pile caps, and then on those pile caps, we had precast panels that we would use to build our bridge deck. And so every weekend we would excavate a piece of roadway, put in the temporary bridge deck, restripe that portion of the roadway and reopen it first thing on Monday morning. And we just methodically went down through Flower Street each weekend until we had a full bridge deck over this area. I don't think the general public had any idea what amount of construction was going on beneath their feet as they were driving and walking in this area. But since that time, and when we were doing our backfill, we had to repeat the process as we were removing the bridge decks. We had to each weekend close the roadway, remove the temporary panels, put in the backfill, rebuild the roadway, and we just kept doing that. We did the same process all over again. So yeah, that was probably our most challenging traffic-related area on the project.
Yeah. Thank you, Michael. Actually, our office is close to 5th and Flower, so I know a lot of the difficulties we have getting in and around that area. Not during the weekdays because as you said, it was closed. But we saw a lot of the activities. I do have one other question posted by Nick Trimble, which is the question is what kind of seismic loading was considered for during construction condition for such a large and long-term project?
Yeah, great question. And unfortunately, I was not directly involved in that piece of the design. That actually happened before I got on board. So again, it was done in 2014. But I can tell you, and I can get a better answer on this. I'll get back to you. But I can tell you what I do know is that we did perform a seismic dynamic analyses on all of our shoring systems. As far as the exact loading parameters, like I said, I don't recall off my hand. I'll have to get back to you. But because of the sensitive nature of all of our shoring systems, before the city would even allow us or issue an excavation permit to us, we did have to prove to them that our shoring systems would be stable in the event of seismic activity. So we did both static and dynamic analyses. So, sorry, I don't have a better answer for you right now, but I'll get back to you.
No, I mean that is pretty detailed in terms of looking at the importance of seismic loading. I think we all live and work in LA, where this is a key component. So that's a standard analysis that we do over here. One other question I have, I think I was listening to your presentation about the boring machine and the boring. I think you said you used the Harrington boring machine. And you applied some of the lessons learned from the Big Bertha tunnel up in Seattle. And I know that got stuck, if I read the news correctly, hitting a steel pipe. And you survived hitting a H pile over here. Is that any special design you have to do to upgrade your machine, sort of expecting the unexpected during boring?
The short answer is this machine was not designed to go through steel piles. Not designed to do that. That was completely an unknown event. It could have been very bad for us. The Big Bertha, I think they hit a relatively small diameter pipe that I understand was left in during I think. So either some groundwater monitoring or there was a relatively small pipe damaged that machine. Or at least that's the word. So no, Yoga, I don't think you can. I don't think Harrington designs its machines to go through these types of obstacles. There's supposed to be enough due diligence that's done. There's supposed to be good enough, investigation done to avoid hitting these obstacles. I think we were just very fortunate, and I think it shows that the Harrington unit was over-designed, which wasn't a bad thing. So, yeah.
No, I would agree. I mean, I think you said during a presentation about you were looking possible emergency maneuvers if the machine was stuck and you didn't have to do that. And there's And looking at the photo here, I mean, threading through those existing tunnels and sewer line or the storm drain, that's an amazing feat by itself. I do have another question um, on the SEM construction and for stability. Was that within the Fernando Formation? And is there any difficulties during that construction? And how deep was the tunnel in that particular area?
Okay, great questions. So first of all, it was all in the Fernando Formation, and were it not for that, I don't know if Metro would have been able to accept the risk of this type of construction if it were, if it were a less stable soil system in this area. So we were very fortunate that we had the Fernando Formation that we were working within. We planned for the worst case, but this was actually, I'd say, one of the smoothest aspects of our project, surprisingly. So no, we had, other than the predicted settlement directly at the roadway above near the crown, we had really no surprises here. So yeah, good news all around, and maybe this is something that Metro will look at again, using where the soil parameters allow us to do so.
Very good. I don't see any questions, Brad. I want to know how much time do we have, or is that?
Yeah, I think we got to absolutely everything. So Yoga, thanks for moderating all that. And Michael, thanks for a great presentation. I think a couple of cool things about this for us. Every now and then on Tuesdays, we run Tunnel Tuesday on our social media feeds. And now I think we've got this. We have one more project we can be on the lookout for that we can include in that and showcase to all of our followers. The other really cool thing about this is it's running right next to where Geo-Congress is going to be happening in a couple of months. So when everybody comes on site, they're going to be able to experience a little bit of this, which will be very cool. So thanks to both of you for doing this. And for our viewers, thanks for everybody who asked questions today and engaging in the way that you did. I hope everybody enjoyed the presentation. We will have one more Geo-Congress sneak peek in the month of February. Look for details on that very soon. And hopefully, not confirmed yet, but we might have a special Geostrata Extra involving LA in some way coming in March. So again, if you liked what you saw and you're here at the end, so you probably did, click like, subscribe, get notifications, and of course, we will let you know every time we post something to the YouTube channel. You can get more information on Geo-Congress at geocongress.org, and I hope we see you there at the end of March. Have a great afternoon, everybody.
Says it's time to close now. I guess I better go now. I really like to stay here all night. The cars crawl past, all stopped with eyes. Street lights share, there were highlights.
take a